Hi everyone, welcome to another video. We're looking in this video at a brand new idea, this thing called inverse functions. Now, we've heard the word inverse quite a bit before, but inverse functions and applying this idea of an inverse to an entire branch of graphs called functions ends up being a really big topic. So this video is going to serve to give us a bit of an introduction into understanding and defining inverse functions, and over the next few videos we will look at some more concrete examples. This is just going to be a slow introduction into this. Now let's look at this word inverse. Where have we seen this? Well, we've seen this for when we looked at, for example, inverse operations. So we did this when we looked at, for example, equations. So if we wanted to solve, for example, 2x plus 3 equals to 6, we applied what we called inverse operations to getting these values away from the x. So when we did, for example, we had plus 3 here, an inverse operation to that would be to minus 3. So it's the idea of doing the opposite. So when we solved equations, we looked at inverse, and here it kind of meant opposite operations. So if we're multiplying by 2 on this side, for example, to undo that, to do the inverse operation, the opposite operation to undo that thing, we're going to divide by 2 from both sides. So we've already looked at this idea with equations before. We also looked at, in this series, inverse proportion. And this was with some graphs which had a particular pattern to them, where they looked something like this, where we noticed that the x and y variables, they interact in a very opposite way once again. We noticed that, for example, over here on our graph, as x gets small, so as the value of x, so on my x-axis, as this value of x gets really small, my y gets big. We also notice that down here, as y gets small, x gets big. So we notice this type of opposite idea happening again. So we said that this relationship between my variables x and y, they're inversely proportionate or proportional. So as one gets bigger, the other gets smaller. As one gets smaller, the other one gets bigger, and vice versa. So once again, we have this idea of opposite. Something opposite kind of happening. So let's apply this to graphing out some functions. So we're going to apply what we sort of have an idea about with the word inverse and try to apply it to a couple of functions. Now I'm starting with linear ones because lines are the easiest to work through. Let's actually look at this. I have a table of values that I've drawn on the left-hand side here, and I have drawn these points on an XY axis, which I can make into a line. Now, applying this to functions, now remember functions are types of graphs where one value of x produces one value of y. What we're going to do is, why don't we think of this idea of opposites and apply this to my x and y variables? What if I were to say that these link up with the opposite value? So we're going to swap x and y here, and we're going to swap their values around. So x is doing the opposite, has the opposite value, and y has the opposite value. Let's have a look at what we actually get there. Now, first of all, let's write the equation of this line. So this is a line with a gradient of 1, because as x goes up by 1, y goes up by 1, and it has a y-intercept of 4. So the equation of this line is going to be y equals to x plus 4. And what we're going to do now, we're going to swap these values. We're going to take this opposite idea and apply it here. So instead of x being -1, we're going to take the opposite value, the y value of 3. Let's actually do this in a different color. Okay, and then y is going to be -1. And we're going to go all the way around here. And we are doing the opposite. We've effectively swapped x and y. Now let's go ahead and plot these points here and have a look at our resulting graph. So here we're given when x is 3, y is -1. So when x is 3, y is -1, that's here. When x is 4, y is 0, that's here. When x is 5, y is 1. When x is 6, y is 2. That's here. Okay, so if we were to draw this, we have another line. Now let's look at what this line's equation would be. Well, this is a little trickier because we know it's still got a gradient of 1. So we have that y equals to, we have a gradient of 1, x, and let's see where this would extend to if I keep going down. So when x goes down by 1, y goes down by 1. When x goes down by 1, y goes down by 1. And finally, until we get to our y-intercept, we can count that. That goes 1, 2, 3, 4 spots down in the y-axis. So we have the equation of y equals x minus 4. Now let's take a look at this particular thing here, because what we've done is we've effectively changed my x's and y's here. So if we rearrange this equation, so if I, for example, add 4 to both sides to get the x on its own, I'm going to get x on its own, I'm just swapping where these are in my equation, equals to y plus 4. Now let's have a look at what's actually happened here. My x's and y's have swapped places. The constant is the same, but if I were to rearrange my second equation, my variables have changed. Now these two are examples of what we call inverse functions. Now, it's not as easy to see here, but let's just look at where these two kind of look similar in some way. Well, they're both lines, and do they look like they look like they're parallel, don't they? But let's look at if they're reflected in a type of way. Because remember we looked at reflections before for our different types of transformations. Let's just see if there's a certain mirror we can draw in here between these two lines where one is reflected along the other side. So if we take, for example, these points, I have here -4 and +4. The middle of those two is going to be around here. Taking these 2 points, -3 and 5, the middle of those two numbers is going to be 1. And I can go up and up and up and up here. And if I draw a line through, I end up with what looks like a reflection line. Because if you sort of tilt your head a little bit, you can see that on either side of this green line I've drawn, there is like the other graphs sit perfectly reflected from one another. Now this graph has a particular name. It's got a particular equation. Let's just investigate it quickly. Well, this graph has a gradient of 1 because as x goes up by 1, y goes up by 1. Has this idea here. And its y-intercept is 0. This is the line y equals, the coefficient of x is going to be 1, the gradient. So I can just write x. And I'm plussing 0 to that because my y-intercept is 0. But I don't need to write that. My line here is what we call, has the equation y equals x. So this brings us to a definition of some way that we can talk about inverse functions. And we're going to explore this definition a lot more in the later videos. These inverse functions these are reflected. What tells us if these are inverse functions is if they are reflected around the line. Now we're not reflecting around an axis like we did before. We're reflecting around a line here, y equals 2x. And if we look at examples of inverse functions, they're written out in the same way, but comparing this one here with this one here, the y and the x are flipped. They are swapped over. That is what makes functions inverse functions. And we're going to talk about this a lot in the later videos. And one final bit to wrap up today is just a bit of notation. So we've defined inverse functions. These are functions reflected around the line y equals x. So if a regular function is given by, if another way we can say y is saying f of x, remember this is our function notation we talked about before. So instead of writing sometimes y equals something, we write f of x equals something. So this is my function notation. My inverse function, I can write as, instead of f of x, I write f to the power of -1x. Now, what's important here to understand is that this is just notation for an inverse function, but this does not mean the function to the power of -1. That's not what we're saying. This is just notation for the inverse. This is just another way to write an inverse function. So this thing here, instead of function notation, this is going to be our inverse function notation. So the power of -1, what we learnt from, for example, what we learnt from indices, when applied to functions with this notation, it's important to note that this is not a reciprocal, which is what the power of -1 would usually tell us. This is not a reciprocal. This is just a type of notation to show inverse functions as opposed to our regular functions and our regular function notation that we're used to. But We're going to get into a lot more of the nitty-gritty with drawing these and understanding these more, but this was just a slow video just to introduce you to some key ideas, the main one being this one, that inverse functions are reflected around the line y equals x, as well as some notation, and also showing you this visually, how something like this would work. In the next few videos, we're going to cover a lot more. But that brings us to the end of the video today. Thank you so much for joining me, and I'll see you next time.